So in this class, we are going to consider our electric circuits. This is a June 2022 exam that we are going to have working with the electric circuits from our physics for grade 10. So that is, you are given question number 5, circuit 1 and circuit 2. The first one and the second one, these are the two circuits that you are given, consist of a 12-volt battery connected to a 24-ohm resistor and a light bulb with a resistance of 16 ohms. Okay, we want to be careful. We want to be very careful because this information here that we have is affecting both circuits. This circuit, it is having a resistor of 24, which is this one. Also here, a resistor of 24. A light bulb of resistance of 16 ohms, a light bulb of resistance of 16 ohms, and also the voltage source of 12 volts. So it is the information affecting both circuits. But now, if we consider the first circuit, these two, because this is our light bulb here, we consider our light bulb, okay, which is the same here. This is our light bulb. So if we consider the connections that we have, according to the first one, as we know, guys, the current is going to flow like this. It branches through this resistance and another current in the other branch, meaning to say this is a parallel circuit. The current is not the same. But in the second circuit, the current is flowing throughout, being the same like that. So this is a series circuit. So we have got a series circuit, a light bulb, we have got resistance. So we consider these resistors in series and these resistors in parallel. The resistor of the light bulb to the resistor of this part of our circuit, they are in parallel. But on the second one, they are in series. So here we are talking about a series connection. And on this one, we are talking about a parallel connection. We must be able to analyze this. All right. So the first question was on 5.1, define the term EMF. That is our electromotive force. Define that. The EMF, which is our electromotive force. So we know that the EMF is the maximum energy given to each coulomb of charge passing through a battery. So this is simply the maximum. So there we have got the maximum energy given. So this is the maximum energy given to each coulomb, All right, so the coulomb is the unit of charge. So to each charge, okay? The unit of coulomb, which is the coulomb of what? Of charge passing through a battery. So this is passing through a battery. So that is what we are going to have. So remember that the coulomb, this one is simply the unit that you consider for Q, which is our charge. Remember Q, which is equal to the product of the current and the change in time, which is in seconds. And this coulomb is measured in what? I mean, the charge is measured in coulombs. So that is the idea of the question there. Okay, so that is what you're given. So it was a direct part, as you can see. Then 5.2, describe the arrangement of the resistor and bulb in circuit 1. In circuit 1, you are working from circuit 1, this one, our circuit 1. Remember, I talked about this. This is a parallel circuit. So this is a parallel arrangement. The arrangement, they're asking you, how are the resistors connected? Are the resistors in parallel or in series? So from the circuit 1, these resistors are in parallel. Okay, we say these ones are in series on the second one. If they were to ask you this, it was going to be a series. But this one, it is a parallel. 5.3, we are given for circuit 1. Take note, they even try to write this in upper caps and also to put it in bold. so that you see that you are working from circuit one, for circuit one, this one. This is where you're supposed to do these calculations. Calculate from circuit one. Calculate 5.31, the equivalent resistance. So that is the total resistance of the circuit, which is our equivalent resistance of the circuit, which is from the circuit one. And I said from circuit one, these are in parallel. Take note, I said they are in parallel. So this means you are supposed to calculate using the formula for parallel circuit. So if you've forgotten this, you have got this information from your information sheet or your formula sheet under the electric circuits. This is where you're going to check the formulas that you're given. So you're given these formulas under electric circuits, at least that you can work with or that you're going to use. So this is for a parallel circuit. 1 over Rp is equal to 1 over R1 plus 1 over R2 and so on. If it is a series circuit, you're going to use this one, but as we need this one because our combination is in parallel. So at least you've got some formulas that you have that you're given. So you just have to apply your formulas. All right, so let's check what are we going to have at the end. That's 5.31. So in 5.31, we saw that this is in parallel, and from our formula sheet, we are given this as 1 over Rp is equal to 1 over R1 plus 1 over R2 and so on and so on. So we are going to add the other part and so on. So this simply means 1 over this. Like if you consider to say, these are the resistors, so you can consider to say this is your R1 and this is your R2. All right, you just have 2 resistors there. So meaning to say 1 over Rp is equal to 1 over, you take the first resistance from our first resistor, that is 24, plus 1 over the second resistor of the bulb. So the light bulb, it has a resistance 16 ohms. This is resistance. Remember, your resistance measured in ohms. So there is resistance there. The light bulb, it has a resistance. So this is you guys and your mathematical calculations. So you can use your calculator to simplify 1 over 24 plus 1 over 16. Then after that, you find the reciprocal, because this is 1 over Rp. This is not Rp, but 1 over. Okay, this is it. Let us have our calculator. 1 over 24 like this. Then you add 1 over 16. So that's 1 over 16 like this. So this is going to give you 5 over 48. So you're going to obtain 5 over 48 like this. So let us go back to our mathematical calculations, guys. You are doing mathematics, so this is an advantage. How do you calculate Rp if you're given this? You can simply find the reciprocal of this, the inverse. So I want you to note this one, that if you're given something like this, 1 over x like this, remember what we say, this means 1 over means the reciprocal, the inverse of this. So this is equal to x. Okay, 1 over this is x. So if it's 1 over 2 like this, it means this is equal to 2. So it's just the inverse of that. Okay, so the inverse, that is 1 over, means the inverse. So the moment I just do this one, because I want to find this Rp, this one. So as you can see, to find this x, to have this x written here, like x there, okay, you've got 1 over x, but you want to write it as x. So the moment you write this as 1 over this, you are now having x, which is the reciprocal. So in the same manner, just put it in your mind to say, I want to find Rp. So what I'm going to simply do is to have 1 over this. So 1 over this, it also means this is going to be interchanged. So you interchange also this side. So what you simply have when it is like this is how you can conclude. Whenever you have this type of equation, this is how you simply find your Rp. You interchange this side, also interchange this side. So it's Rp over 1 like this. Rp over 1, which is Rp. So if I interchange this side, I'm obtaining RP. I have to also interchange what I have done on the left-hand side must be done also on the right-hand side. So I interchange that. So it'll be 48 over 5. I just flip over. So that is 48 over 5. And thus as a decimal, we can also write this as a decimal. It was going to give you 9.6 ohms. Remember, this is resistance. You're supposed to have the unit of measurement properly given. That is the ohms. So that is the total resistance that we have of the parallel combination in parallel. The total resistance is 9.6. All right. On the same circuit, we are still on the same circuit. If you consider 5.32, we are still on the same circuit, still for circuit 1, but now we need the current that passes through the light bulb. Take note, this is a parallel circuit, as I demonstrated before, that in a parallel circuit, you are going to realize that the current is moving from the positive, as we know. So it's going to move like this. Let's say this is the total current. The total current, which was calculated from the total resistance, it is going to branch as it reaches this point, which is our connection. It branches, another current flows through this resistor, another current, it flows through the bulb, which is our light bulb. These two, they are not going to have same current. No, they are going to have different currents. Let's say this is current 1, and let's say this is current 2, which is flowing through our light bulb, which we are considering as our resistor 2. So they are not going to have the same current, no. But what happens in a parallel circuit is that this voltage that we see here across, it is the same. It is the voltage that we see across these points. It is the same voltage that we also see across these points. So it means the voltage of 12 volts is the same. There is a 12 volts on this resistor. There is also a 12 volt on the battery. The voltage is the same in the parallel circuit. So in the parallel circuit, we know that there is same voltage. In a series circuit, we consider the same current. But in a voltage circuit, it is in a parallel circuit, it is the voltage which is the same. So if the voltage is the same, it means there is a 12 volt here on the bulb. And remember what you want to calculate. It is to calculate the current that passes through the light bulb. So on the light bulb, there are two things that you have now. There is the resistance of the bulb. There is also the voltage across the bulb. If I have the resistance and also the voltage, what can I obtain from there? The current. So it means we can obtain the current from there. Take note, this was a mistake from our memo to use this resistance of 9.6 to calculate this current here. No, it's not like that. The resistance is for the total circuit. So it means it affects the total current. And the total current at this point here, let's say this is our total current, it is not the same as this one. It is not the same as this one. No, the current is divided into two. So you do not use the voltage and the total resistance. No. In a parallel circuit, you consider the voltage to be the same. So you're going to use the voltage across the bulb. All right. So that's 5.32. So the current there, we are going to have the voltage over resistance. Remember your formulas, where the voltage, you use the voltage across the bulb. So the voltage across the bulb is 12 over the resistance across the bulb also, and that is 16. That is a parallel circuit. That's for a parallel circuit. You have to consider that in a parallel circuit, that this is different like a series circuit. So this was going to give us 0.75 amps if you calculate this properly. All right, so that's our 5.32. Let's consider 5.4 for the circuit 2. Now, where are we? Circuit 2. You are working from circuit number 2. For circuit number 2, calculate 5.41, the total resistance So we need the total resistance from circuit number 2. And this is our circuit number 2, this one. That's our circuit number 2. And in the circuit number 2, this is a series combination that we have. And in the series combination, how do you calculate the total resistance of a series? It is the sum. You add the resistors. All right, so in a series circuit, you simply add the resistors. So that means 5.41, our RS is going to be the resistor R1 plus the resistor R2. So let's say this is our R1 and this is our R2. So you're simply going to add, that's our RS is going to be 24 plus this second resistor, which is 16. That is going to give us the total resistance of 40 ohms. So that is how you can calculate this. All right, let's move on to 5.42, which is again for circuit number 2. We are still on circuit number 2. Now we need the current passing through the light bulb, and that is 2 marks. So the current passing through the light bulb this time, because it is a series combination, we do understand that in a series combination, it is the current which is the same. So in a series combination, we have got the same current. So if we have got the same current, what does it mean? It means the current through this resistor R1 is the same as the current through the resistor R2, which is our light bulb. We have got the same current. So if we have got the same current, it's an advantage that we can make. We are simply going to calculate that to be the total current. So the total current, which I can just write as IT, is same as the current across our light bulb. It is the same as the current across R1. So meaning to say, we are simply calculating the total current of the circuit, which is opposed to a parallel circuit. In a parallel circuit, it is not like that. The current is not the same. It is the voltage which is the same. So you must be able to understand that. So that is the voltage 12. All right, so let's have our formula, voltage over resistance. So we are going to use the voltage 12, and the resistance is the total resistance of the circuit. Remember, we are saying the total current is the same throughout. So if it is the total current, it must be calculated from the total resistance of our series combination. So that is going to be our current in that case. And if you were to divide this, you are going to obtain 0.3. Do not forget the units. So therefore, our current is going to be what? 0.3 amps. Current is measured in amps. Resistance is measured in ohms. Just like that. Just like that. Okay, so let's consider another question, which is 5.5. Calculate the charge that places. All right, so we need to calculate the charge that places, that passes, sorry for that, that passes through the light bulb in the circuit, in circuit 2, when the current flows for 2 minutes, and that is 3 marks. So we're gonna need to calculate the current that is the charge there, that we're gonna calculate, and this charge, it passes through the light bulb in circuit 2. So this is from circuit 2. Take note, we are given where to consider from circuit 2. So we are from circuit 2. So that's 5.5. We need to calculate the charge, which is Q, but we are from circuit 2. All right, so this is to be calculated from circuit number 2. So they are saying the charge that is that passes through the light bulb and it flows for 2 minutes. We are given the time. The time frame is 2 minutes. So we are given the time in minutes. Remember, whenever you're calculating charge, the time is supposed to be in seconds. We're going to talk about that. So they want you to calculate the charge across the light bulb. This one, across the light bulb. Okay, so let's consider that our charge can be calculated from the formula, which is current times the change in time. which is a direct formula indeed. So if charge is equal to the current times the change in time, this is measured in seconds. This is our current in amperes. So the current that we need is the current across the bulb, because you are told the charge that passes through the light bulb. So the charge across the light bulb, it means we are supposed to consider the current across the light bulb. But because this is a series combination where the current is the same, we are going to take the current for the total circuit, for the whole circuit that we had, which is the total current of 0.3 times the change in time, that is the time frame, through the time 2 minutes, but the time is supposed to be in seconds. So you must convert minutes to second. Remember, in a minute, you have got 60 seconds. This is also your mathematics. So you're just going to multiply by 60. 2 times 60 to convert to seconds. So that is going to give us 36 coulombs. All right. So the unit for charge is the coulomb. All right. So these are coulombs. So you just write a C like that. That is the unit of what? The unit measurement of charge. So this is how your questions can be given as. Then the last question, which is 5.6. In which circuit, circuit 1 or 2, does the light bulb shine the brightest? Take note. We need a condition where the light bulb shines the brightest. Justify your answer. It is simple, guys. For a light bulb to shine brighter or to be the brightest, it must have a higher current compared to the other one. So we've got 2 light bulbs in this case, this one and the second one that we have here. So in order for us to have, or to have this light bulb being the brightest, it must have a bigger current. Remember, you calculated the current across these light bulbs, so we can even verify from there. The first one, 5.32, we calculate the current across the light bulb number 1, which is from the circuit 1. We also calculated the current passing through the light bulb from the circuit 2. So we can compare using the currents. Take note. From the first one, our current here was given as 0.75, which is from circuit 1. The light bulb, it has a current of 0.75. If we check from the second one, the light bulb, it has a current of 0.3. So comparing these two, 0.75 and 0.3, which one is bigger? It is 0.75. It means the light bulb from circuit number 1 is going to shine the brightest. It is going to be the one with the brightest. It's because of what? The higher current compared to what we can see there. It has got a bigger value when it is compared to the current. So that is how you can actually have this, or you can specify that connecting resistor, because if the resistors are being connected, so you can also justify this way that here we've got a bigger current, because if you connect resistors in parallel, it decreases the total resistance of the circuit and thus increasing the current. Connecting resistors in parallel decreases the total resistance and thus increasing the current. So you can also put it that way, or you can compare with the currents that you can see where there's a bigger value of current or the larger value compared to another one. That is where we are having the light bulb that is going to shine brighter compared to another one. So it was going to be from the first circuit. So please do so to revise as much questions as you can, so that you are able to prepare for these exams which are ahead of time.